All right, just want to do a quick video showing you guys how to answer these questions here at the end of the notes. And first of all, it says how many sublevels can be in the fourth principal energy level. And again, this should have been redone. Again, your notes may say how many electrons, but it should be how many sublevels are there. That's what you need to know. And again, whatever the energy level is, if the energy level is 4, that's how many sublevels you can have. So in that case, you can have S, P, D, and F orbitals. If the principal energy level is 2, you can have 2 sublevels, just S and P. So that's how you would know that. You can do the practice next. How many electrons in the outer energy level of nickel? Nickel's atomic number is 28. You look it up on the periodic table. Then you would have to do electron configuration for that. So again, we would use this to do those. And you start at the top. And again, the first 2 electrons would go in 1s2. Once you go through that line, go up to the next one and start. That would be the next level you'd fill up. That'd be 2s2. And then after that, go back here. Remember, when you're filling up the p orbitals, you can put a total of 6 electrons in them. And then 3s2, 3p, 6, 4s2, and 3d we've already counted for 20. There's 8 left. Because remember, we can put up to 10 electrons in the d orbitals. But this is how many in the outer energy level. Remember, the energy level is determined by the principal quantum number, which is this number listed here. This nickel has 1 level, 2 levels, 3 levels. Its outermost energy level is actually 4, level 4, and that's why the answer there is 2 and not 8, because that's part of level 3. So level 4, it's got 2 electrons. You can do practice there on the next one yourself. How many half-filled orbitals does phosphorus have? Again, its phosphorus atomic number is 15. You can find that from the periodic table. Do a configuration for that. 1s2, 2s2, 2p6, 3s2, and 3p3. But you need to do a spin diagram to know how many half-filled orbitals or how many unpaired electrons. It's the same question. And so what you do at the end there is do a spin diagram for this. You need to put dashes across the bottom to show how many p orbitals you have. Remember, there's always 3 p orbitals. If you're going to place 3 electrons in them according to Hund's rule, you can't put 2 in the first box or 2 in the first orbital, 1 in the second. You have to put 1 in each one of those, because those are all equal energy orbitals. You got to put 1 in each one. The electrons get as far apart from each other as they can, so the answer to that is 3 half-filled orbitals. Those are all half-filled. You might say, why not look at the rest of them? The reason you don't have to do a spin diagram for the rest of that stuff is they're all paired up. All those orbitals there are filled up. Only the last sublevel would be an issue there. There are some exceptions, but you're not responsible for those. All right, moving on to the next few questions there. It says, which electron sublevel has the lowest energy? Now, I don't expect you to just randomly guess that. You can go to this. This is arranging them from lowest energy to highest energy down here at the bottom. So the question is 4s or 3d. You fill up 4s, then 3d. That means 4s is the lowest energy there because it fills up first. These are from lowest energy to highest energy at the bottom. So you use this. Remember, this will always be given to you on the test. 34, what types of sublevels are in the fourth principal energy level? Remember, the number of sublevels in the level is equal to the level number. So level 4 has 4 sublevels, S, P, D, and F. Level 3 would have 3 sublevels, S, P, and D. All right, 36, maximum number of p orbitals in a principal energy level. The number of orbitals that you can have, S, P, D, and F, are always fixed. There's always 3 p orbitals. If I ask how many s orbitals there are in a potential level, it's always 1. And so you can answer the next question based off of that. Principal quantum number indicates what? Again, that's what these numbers are. They're just telling us the level that electrons are in. So that's what that's telling us there. Principal quantum number telling us the level. That's it for this part.